Welcome you all to this new lesson of circuit theory. Today we'll be discussing some more problems on basic electric circuits. So before starting today's discussion, let me summarize the past few classes which we discussed. In last few classes, we discussed about basics of electric circuits, what are the different terminologies associated with circuit theory, different rules which are used to calculate current through a particular branch or voltage across a particular branch. We discussed about voltage divider rule, current divider rule, series parallel combination of inductors, capacitors, and resistors. So all those been discussed in last few classes. In just last class, we discussed some problems. We solved some problems on basics of electric circuits, applying all the knowledge that we acquired previously in for this course. Today we'll discuss some more advanced problem on electric circuits. So let us start our discussion. Today we'll be discussing some problems. So let us start with this problem. For this problem, it is mentioned that find out current through each branch of the circuit. So how to find current through each branch of this circuit? It is having one voltage source. It is having one voltage source of 10 volt and few series parallel combination of resistors. So whenever we are asked to find current through each branch, see, first you need to know the main current. We'll be applying current divider rule to get the total current. Suppose this current is I. Say this is I1. This is I2. This current is I3. And this current is I4. So as per the question, we need to find all the currents here, I1 to I4. So first what we need to do, see, to find I1, we need to know what is I, because I1 is divided current of I. So I is total current, which is divided in I2 and I1. So to determine I1 using current divider rule, I need to be known. Similarly, to determine I3 or I4, see, I2 current is getting divided into I3 and I4. So to determine I3, I2 current need to be known to us. So how shall we proceed? First, let us determine I current. I is total current of the circuit. Now I should be total current, which is equals to total voltage divided by total resistance. This implies to determine I, we need to know R equivalent. Now as per current division, see, total current I is getting divided into two currents I1 and I2. Now I2 further will be divided into I3 and I4. So as total current I2 is getting divided into I3 and I4, so we can say these 2 ohm resistors are connected in parallel. So by solving this, 2 parallel 2 means R1 R2 by R1 plus R2. This is formula for equivalent resistance calculation of parallelly connected resistors. So 2 into 2 4 by 2 plus 2 4. So parallel combination of these two will be 1 ohm. Now after making parallel combination of these two, we'll get 1 ohm. With that 1 ohm, there is 3 ohm. 3 ohm. There is a voltage source here, and there is one resistor of 4 ohm. Now 3 and 1 are in series, so total resistance will be 4 ohm. Now this 4 ohm, combination of these two resistances, these two together will form a 4 ohm resistance. Now with this 4 ohm is connected in parallel, because total current I is divided into I1 and I2. So what would be equivalent resistance in this case? 3 plus 1, that is 4. This 4 will be in parallel with this 4. So 4 parallel 4 will be 2 ohm. So equivalent resistance is 2 ohm. So I will be 10, that is V is 10, divided by equivalent resistance will be 2 ohm. Which implies a 5 ampere of total current will be drawn from the battery. So whenever I is known to us, see I is known to us, now I1 will be equals to I2, equals to 5 multiplied by 4 by 4 plus 4. Why this is so? Because this is 1 4 ohm and this combination is 4 ohm. So I1 is flowing through 4, I2 is also flowing through 4. So whenever you are finding I1, as per current divider rule, I1 equals to total current I, that is 5 ampere, into I1 is flowing through this 4. So which one is opposite resistance? 3 plus 1 4. 4 is opposite resistance, which will be placed here, divided by 4 plus 4. So I1 equals to 2.5. I1 equals to 2.5 ampere. Similarly, I2 will also be equals to 2.5 ampere, because both are same resistors, 4 ohm, 4 ohm. So whenever you are finding I2, opposite resistance will be this 4 ohm, this 4 ohm. So both will be same. Okay. Now I1 is found to be 2.5. So I1 is already found out. I2 is already found out, which is 2.5. Now what we need to find? I3 and I4. See, I2 current is getting divided in two 2 ohm resistors. So I3 and I4 are divided equally. So as per current divider rule, I3 equals to total current I2. I3 is divided current of I2. So I2 is 2.5 ampere. We're finding current through this 2 ohm. So this one is opposite resistance 2. Sum of the resistance is 2 plus 2. So I3 equals to 1.25 equals to I4, as both are having same resistance. So this is how you can find current through each branch by applying current divider rule. Now in this case, what we applied current divider rule to determine current through each branch. First we need to know total current of the circuit. Total current of the circuit can be found out by equating this equation, where Req is equivalent resistance of the circuit. Likewise. Okay. So let us now move to next problem. Here we are asked to find V1 and V2. See, these are series connected resistors. We are asked to find V1 and V2. So simply we can apply voltage divider rule to find V1 and V2 here. So as per voltage divider rule, V1 will be equals to total voltage, that is 20 volt. Total voltage which is getting divided into resistors. So V1 is equals to total voltage multiplied by that resistance, that is 2 ohm. In case of current divider rule, opposite resistance will be there in numerator, but in case of voltage divider rule, that resistance will be there for across which voltage is to be determined. Divided by 2 plus 3. So these are the sum of resistances. So as per voltage divider rule, this will be 5, 4, 8 volt. So as this is 8 volt, similarly, what should be V2? Similarly, V2 will be total voltage 20 multiplied by 3. Voltage across this is to be determined, so this will be in numerator by 2 plus 3, that is 12 volt. Now see, as this is plus terminal, so current will be flowing in this direction. So current through this will be flowing in this direction, and through this resistor will be flowing in this direction. So current always flows from higher to lower potential. So this should be plus, this should be minus. This is plus and this is minus. Similarly, current is flowing in downward direction through 3 ohm. So this should be plus, this should be minus. But in question it is mentioned with opposite polarity, which implies using this formula we are finding V2. But in question it is mentioned of opposite polarity. So actually as per the question, the V2 should be minus 12 volt. So this is how you can apply voltage divider rule to determine voltage across a particular branch. Okay. Now let us move to next problem. Here we are asked to find equivalent resistance of the network looking across this terminal. So while finding equivalent resistance, suppose this is A point and say this is B point. Remember that you are going to reach at B from A. In between the encounter resistance will be your equivalent resistance. So suppose you are at point A, you may go through this path. When you come at point B, okay. Solution of this is given in next slide. I'll make point note. I'll make marking of notes in this diagram to make better understanding for you. Suppose you are at A point, you want to reach at B point. You are asked to obtain equivalent resistance across AB. So if multimeter gets connected across these two terminals, the resistance shown will be the equivalent resistance. Now see here, suppose while finding equivalent resistance, remember that there is no source of voltage, so no current is flowing. Let us assume you are initially at point A, you want to reach at point B. So how can you reach at point B? You must move through this path first. Suppose this is C point. So when you reach C point, you will get this path and this path to follow. Suppose this is D point. And say this is E point. So from C to D, there is one path. from C to E. From C to E you can reach through this path, or from C to E you can reach through this and then these two paths. So to reach at E from C, there are two different paths. One is direct through 1 and 5 ohm combination. Another is via D and through 6 and 3 ohm. So what can we do here? What can you do here? See, from C to E, if you want to reach C to E, we can follow this path. Now in this path, 1 ohm resistor and the 5 ohm resistor, these two resistors are connected in series. So 5 plus 1, 6. So this is A point, this is B point, this is C point. In between C and D there is 2 ohm, there is 2 ohm. In between C and E there should be a 6 ohm. 5 and 1 are combined in series. There is only single path. So 5 and 1 is combined into series. So we have got 6 ohm. And from C to E, there is another path via D. So C to D, there is 2 ohm. But from D to E, there are two parallel paths. One is through 6 ohm, another is through 3 ohm. So from D to E, you can combine these two parallelly combined resistors into a single one. So from D to E, you can get equivalent resistance. 6 and 3 are in parallel. So equivalent resistance will be 6 into 3 divided by 6 plus 3. That is 2 ohm. So what can you conclude? To reach at E from C, you have 6 ohm and you have two combination of two series connected resistors of 2 ohm. One 2 ohm is given here. Another is parallel combination of 6 and 2, which will give us 2 ohm. Okay. Now see, these two 2 ohms are in series. So this 4 ohm, this combination will be 4 ohm. This 4 ohm will be combined with this 6 ohm. So 4 ohm is in parallel with 6. So 4 parallel 6 means 4 into 6 divided by 4 plus 6, that is 10. So 24 by 10 is 2.4. So from C to E, equivalent resistance from C to E will be for this combination. Equivalent resistance will be 2.4 ohm. 2 plus 2, 4. This 4 is in parallel with 6. So this is the equivalent resistance. This is C point, this is E point. In between C and D, there are lots of resistance combined, which is replaced by a single resistance. So in between C and E, there is 2.4 ohm. In between A and C, there is 4 ohm. See, in between A and C, there is 4 ohm, which is kept intact yet. In between D and E and B, there is 8 ohm. Now all these resistors, now you are having only one path to reach at B from A. So all these resistors will be connected in series. So equivalent resistance will be 4 plus 2.4 plus 8. That is 14.4 ohm. Clear? So this is how you can get equivalent resistance for this circuit. Now let us move to next problem. Find REQ for this problem. See, there is a trick in this problem. What's the trick is that we will discuss. In between A and C there is 10 ohm. C and D there is 1 ohm. D and B, there is one combination of 1 and 5. That is, combination of these two will be replaced by a 6 ohm resistor. And in between D and B, there is another resistor that is of 4 ohm. Okay. Now, in between C and B, there is 3 ohm. In between C and B, these two are same points. In between C and B, there is another 6 ohm. In between D and B, there is 12 ohm. So what can we conclude here? In between D and B, there is one 12 ohm and one 4 ohm. So from D to B, from D to B, from D to B, there are three resistors combined. One is 12 ohm, one is 4 ohm, and another is 6 ohm. So if we combine 12 and 4, these two in parallel, see here, in between D and B, this 5 plus 1, 6 ohm is mentioned here. In between D and B, there is 6 ohm. But in between D and B, there are two more resistances connected in parallel. One is 4, another is 12. So combining these two resistors in parallel, we will have 4 into 12 by 4 plus 12, that is 16. So this will be 3 ohm. So in between D and B, there is 3 ohm. So this 3 ohm is parallel combination of 12 and this 4. Now, in between C and D, there is 1 ohm. In between C and D, there is 1 ohm. In between A and C, there is 10 ohm. There is 10 ohm. In between D and B, there is 6 ohm. There is 6 ohm. In between D and B, there are two resistances, 4 ohm and 12 ohm, are connected in parallel. So combining these two parallel combination, we'll get 3 ohm. Similarly, in between C and B, there is one 3 ohm. C and B, there is one 3 ohm. And between C and B, there is another 6 ohm. So combining 3 and 6 in parallel, these are in parallel now. From C to B, there is one 3. From C to B, there is another 6. So starting point and ending point for both 3 and 6 are same. So these two will be in parallel. So in between C and B, 6 and 3 are combined in parallel. So parallel combination equivalent resistance will be 6 into 3 by 6 plus 3, that is 9, which is equals to 2 ohm. So in between C and B, there is 2 ohm. Okay. So this combination can be redrawn like this. Now see, in between D and B, there are two resistors connected in parallel. So 3 parallel 6 will be 2 ohm. So here a mistake is made. This 1 ohm is missing here. This is D. In between D and B, 6 and 3 are in parallel. So 6 parallel 3 will be 2 ohm, and this is 1 ohm. In between C and D, there is 1 ohm. So combining these two in series again, you will get 3 ohm. So which is one step jump is made here. Directly it is written 3 ohm. Why this 3 ohm? 6 parallel 3 will be 2 ohm. With this 2 ohm, this 1 ohm is in series. So this is 3 ohm and this is 2 ohm. Now these two will be combined into parallel. 3 into 2, 6 by 5. So combining these two into parallel, we will get like this. A 10 ohm, C B. In between C and B, there is one 2 ohm and one 3 ohm. So parallel combination will be 1.2 ohm. 3 into 2 by 3 plus 2, 1.2. So equivalent resistance will be, Req will be 11.2 ohm. This is the equivalent resistance of the circuit. So this is how you can solve the problems. Uh, in next class, we'll be solving some more problems on this basics of electric circuit. So as of now, for today, I'm ending up here. So meet you in next class. Thank you all.